Hi, I am Ravi Kumar. In this video, we will see the T flip-flop using NAND gate, and also we will see the truth table, excitation table and characteristic table for the T flip-flop. You know the JK flip-flop diagram. This is the JK flip-flop diagram, and you can convert the JK flip-flop to T flip-flop just by connecting J and K as a single pin here. Now we'll see how this one. See, T flip-flop generally function is, if the T input is 1, then output should be complemented. If T input 0, output should not be complemented, it will remain as it is. That is the T flip-flop function. So now observe here, if I am giving T is equal to 0, if T is equal to 0, then output should not change here. Output should not change means, when the JK flip-flop output should not change here, when J and K inputs are 0, 0, then the Q output is not changing. Why? Because it is in memory state. So that is, if it is 0 here, that 0 is passing through J, and also that 0 is passing through K. So that is, if T is equal to 0, J 0 and K 0, then the output is not changing, it is in memory state. So now our function, our truth table is obeying by using this diagram. That is, if T is equal to 0, output is equal to same state only, it is not changing. If T is equal to 1, then J is equal to 1, K is equal to 1. Then if T is equal to 1, then it has to toggle. So that is, if T is equal to 1, J is equal to 1, K is equal to 1. If J is equal to 1, K is equal to 1, then the JK flip-flop output is nothing but Q bar here. You know that one. So that is, the JK flip-flop can be converted into T flip-flop just by adding one line between J and K and taking as a single input to the T pin here. So the same thing here we have drawn here for the JK flip-flop diagram, so that it can obtain the T flip-flop here. Now the truth table is, if the T input is 0, no change in the output. If T input 1, you can have to complement the output. So that thing is represented in characteristic table. The characteristic table is represented as, so what is the output if I am applying this input and that is in this state. So if I am applying 0 input and it is in 0 state, what is the output in this case? So that thing can be represented by using characteristic table here. So T I am applying 0 means, so whatever the previous state, that is 0, that should be reproduced at the next state also. So it is 0. T is equal to 0 means the same thing will appear in the next state also. So that's why it is 1. If T is equal to 1, then the output should be complemented. So previously 0 is there, it is complemented to 1 here. If T is equal to 1, the output should be complemented here. So it is 1 here, then it is complemented to 0. So this is the characteristic table. Coming to the excitation table. Excitation table means, if it is in 0 state, I want to change from 0 state to 0 state again. So what is the input I have to apply here? It is in 0 state, I want to change from 0 to 1 state. What is the input I have to apply here? That thing can be obtained from the excitation table. So that is, previously 0 state is there. So next state is also 0 means what you have to apply? So same state means here from the truth table, we have to apply 0 here. So that's why T is equal to 0, we have to apply here. 0 to 1, that is, you have to get the complement. So to get the complement, you have to apply here 1 here. So 1 I am applying as an input here. So 1, 0. See, 1 is previously. Now 1 has to change to 0 means you have to get the complement. So then T you have to apply as 1 here from this truth table. So 1, 1, no change means here you have to apply T as 0 here. So that's why T you are applying as 0. This is about the T flip-flop. Thank you.